I'm Patrick Donnelly, the CephFS tech lead, and I will be talking today about what we accomplished in Pacific for CephFS and what our plans for the future are. Um, to begin, again, we'll be going through the various features we added in Pacific. You'll notice that many of these slides are based off of what Sage already presented with some modifications. Try to go into more depth in it during this talk, and feel free to stop me at any time to ask any questions you might have. I've also included in the slides, which will be distributed later, the blog post I wrote up, which also includes a lot of these discussion topics somewhat in more detail, perhaps. So the Ceph project has been following 5 themes revolving around the features we've been developing for the last few releases. And that trend will begin with usability. So the highlight feature for Pacific is now that multi-file system support is stable. And it's fairly simple now to create file systems. No longer do you need to do a bunch of pool creation and then CephFS new and then spinning up MDSs. In Pacific, this is now largely automated for you. We have this FS volume interface that allows you to create a file system quite easily, including all of its pools following the best recommendations for Ceph, and automatically deploy MDSs using the distributed or the deployment backend for Ceph, either CephADM or Rook, and bring up as many file systems as you need, and then also remove them as you need. Another usability feature we've developed in that same vein is the MDS autoscaler, which will start and stop MDSs based off of the needs of the file systems you have. This is a module that's not enabled by default. You have to turn it on. But once on, it should create MDSs using the deployment tool, either CephADM or Rook, in response to changes of the configurations of your CephFS file system. For example, if you increase max MDS, the module will automatically deploy another MDS in response to that change. We've also developed a new tool, which is currently developer preview quality, called CephFS Top, that now lets administrators monitor the usage of the Ceph file system with details that were previously not trivial to gather. In particular, clients now communicate to the MDS certain information, which we call metric gathering, concerning the different performance statistics that they have that the MDS would not otherwise be aware of. For example, how effective the client caches are and how much read and write I/O they're putting on the Ceph cluster. This is communicated to the MDS, and the MDS is able to communicate with the Ceph manager to provide a summary of statistics for all the clients in the cluster and display a simple ncurses UI for the administrator, showing the various client sessions in the Ceph file system and what they're doing and who the top consumers are. Again, this is a tech preview, but we are spending time to improve it always, and we are eager for any feedback that the community has. In that same vein, we've also been working on CephFS shell. To my knowledge, we haven't had too much feedback from the community. This has been around for about 2 releases now, 2 or 3 releases. It's a simple Python utility that mounts CephFS and allows you to execute some commands on the file system without having to mount it using Fuse or the kernel. we've been continuing improvements to that, and we encourage anyone who would find that makes things easier for administrating a Ceph file system to please give it a try. We also have a new Snap Schedule Manager module that also must be enabled. That allows you to schedule snapshots on a Ceph file system on a given period, and also retain snapshots according to a retention schedule that's set up. That can allow you to, for example, set up snapshots to be taken every day for a week, and then delete any snapshots that are older than that time frame. This is a module that's designed to be used in tandem with the new CephFS mirror project that we'll talk about later. We also have new first-class NFS gateway support in Ceph. There's a NFS manager module that allows you to create NFS clusters to export CephFS and set up a group of exports to be exported by that NFS cluster. You can set up the NFS clusters in active configurations, or set up and in the near future you'll be able to even set up HA using Ceph ADM with HA proxy. That's work that SageWile is doing right now. Or you can also use Rook for the HA component, although the Rook CRD is under active development right now, so not quite yet. The NFS clusters that are deployed, you can have them automatically deployed using the Ceph orchestrator, so you don't actually need to stand up NFS clusters on your own. You don't have to worry about what types of configurations you should use for Ceph. This is all automated by the manager module and the Ceph deployment backend, so that you don't need to worry about that. We've also been working on adding encryption support to the kernel client, and there have been a few changes that have also been necessary for the MDS. Some of these changes are being adjusted constantly, and the MDS side is not quite ready because the kernel client is still under active development, but we have several changes that are already in the MDS side for Pacific, and we plan to backport the remaining changes necessary to get complete encryption support ready for in the MDS, so that the kernel client may mount CephFS subvolumes and have them be encrypted. Moving on to quality. We had a API set up for setting a minimum client release that you want for clients connecting to your cluster. All right, I think we might have a question. Jeff sharing that yes, we're doing an FS Crypt and Ceph talk tomorrow at 9:30 a.m. Eastern time, if you want to learn more about that. Coming back to the robustness, we have feature bit support for turning on and off required file system features. This replaces the previous behavior of setting a minimum client release, which is historically not been a great design, especially when the kernel client can only selectively backport certain features to bring it to parity with a Ceph release. So a more robust solution is to selectively enable and disable the features that you want, and that is all, the API for that is all set up and documented in the Ceph docs if you want to learn more. We've also stabilized multiple MDS file system scrub that is in the before Pacific, you would have to bring your CephFS file system down to max MDS equals 1, so reduce the number of ranks to 1 before you could run a scrub. This was due to bugs that we knew existed with false scrub errors or incorrect scrubbing when executing a scrub with multiple ranks. We did a significant amount of development to improve that, and now we now support having multiple actives. So you no longer need to change max MDS in order to execute a scrub. In the kernel client, we have support for Messenger v2, thanks to efforts by Ilya. You can just specify a kernel mount option to turn that on now. Also, in the kernel client, we have support for recovering mounts from block listings, so you no longer need to remount your kernel client to have it brought back if it becomes blocklisted by the MDS, and that can be turned on by recover session clean. This doesn't actually allow workloads that we're doing writes to continue because it's generally a non-recoverable error if a application that's writing to the mount tries to come back. But the applications that had read handles on files will continue to function, and new applications running on the mount can do reads or writes. CephFuse has a similar feature or behavior with the client reconnect stale equal 1 configuration, and then also if you want to do this, you should disable the page cache. Finally, just as far as testing CephFS is concerned, we've dedicated a lot of effort into cleaning up our test infrastructure and making sure we're testing clients and MDS configurations, across different types of tests in more consistent ways, and we've doubled the number of tests for CephFS as a result, from about 2,500 jobs to 5,000. So we're now testing a lot more things in the upstream, and we're gaining a lot more confidence in the stability of the system. Moving on to performance. Another big feature that we've had that was partially available in Octopus as development preview was ephemeral pinning. This is now stable. And what this is policy-based subtree pinning. Pinning subtrees has been around since, I believe, Luminous, allowing you to assign a given subdirectory tree to a particular MDS rank. Ephemeral pinning allows you to set a policy saying that you want how you want a directory or a group of directories to be pinned, but you're not actually assigning the pin directory to a particular rank. An ephemerally pinned directory is either ephemerally pinned or not, and where it is pinned is determined by the CephFS cluster. And the main reason for that is it allows the cluster to intelligently distribute the ephemerally pinned directories and also rebalance them if the number of MDSs in the cluster changes. There's two different kinds of ephemeral pins. Distributed pins automatically shard subdirectories, so think a home directory. And then we have random pins, which is just a probabilistic chance that a directory that's been loaded into the cache from the metadata pool or a newly created directory is ephemerally pinned. This is a pretty exciting change for us, and we believe it could have some very attractive performance aspects for a lot of workloads. We're hopeful to get some good feedback on this. Next, we've also spent a lot of time improving the capability in cache management in the MDS for larger clusters. This has been an issue we've been dealing with for quite several releases now, and we believe that the current state of CephFS is much better now and a lot more stable than it used to be. The most recent changes we've made are improving the cap recall defaults for larger production clusters, and that is in response to some feedback we got from Dan Vanderser of CERN. And we also improved the capability acquisition throttling for some client workloads. And what that means is certain workloads like the find command executed on CephFS could acquire huge numbers of caps capabilities via read-dir calls. And that would cause the mount that it was executing on to get way more caps than it should. And the MDS, due to its own throttles, would not recall them fast enough. So now we have throttles for those clients which are acquiring caps too fast and not releasing them quickly enough. All right, and then finally, we also added support for asynchronous unlink and create. We've had partial MDS support for that since Octopus. Many of these changes in the kernel client, which is the only client that does this currently, have already been backported to some of the more stable kernels. In particular, RHEL 8.4 has this. And this feature needs to be turned on with the no wsync flag. And that allows the kernel client to asynchronously execute the create and unlink system calls, RPCs, on the MDS and potentially get big wins in latency. Moving on to Multisite, as I spoke of earlier with the snap schedule module, we also have this snapshot-based mirroring through the CephFS mirror tool. This allows you to figure replication targets, remote Ceph clusters, to be mirrored on and configured for any directory. The CephFS mirror daemon is analog to the RBD mirror daemon, is used to push data from the locally snapshotted CephFS file system to another CephFS file system located on the remote cluster. This is a daemon that's also managed by Roker Ceph ADM. The feature is snapshot based, so you need to have a snapshot of the Ceph file system before it'll actually sync it to the remote cluster. We have an initial implementation in Pacific that we're doing aggressive feature development on. Right now, it supports a single daemon configuration, but that'll soon change to allow for multiple active CephFS mirror daemons that automatically balance the workload. And the HA support is already present. We also recently updated to improve the incremental updating. So it looks at the directory tree similar to how rsync does to choose which files to actually sync. If you have across multiple snapshots, it'll only incrementally send what is necessary in order to do the sync and not resync the entire tree. And again, we'll be developing this aggressively, and there will be more backports to Pacific to improve how it functions. Moving on to ecosystem. We also have spent a lot of time improving the use of CephFS with Kubernetes CSI environments, where CephFS is used for RWX or ROX volumes, PVs. And this is all orchestrated through the volumes plugin in the Ceph Manager, which provides an API for creating and deleting PVs through the what we call the subvolume interface. For Pacific, We added support. We stabilized the snapshots interface for subvolumes and stabilized the interface within CSI. And we have been adding new authorization API support for OpenStack Manila, which is also in the process of porting to use this new API. And also have added ephemeral pinning support for volumes. Another major feature in Pacific is the CephFS Dokken Windows client. This is analogous to CephFuse. And you can use this just like CephFuse to mount the CephFS and then provide access to that on the Windows system. The current code is developer preview, but we've heard a lot of positive feedback on the community mailing list already. It's under active development, and one of the next major steps will be to integrate CephFS Dokken into our upstream QA, so it's tested more regularly. Currently, that's been a big barrier for us. All right, so let's move on to Quincy. For performance, what we would like to do next is add support for asynchronous rmdir, makedir, and potentially also link and rename. This will get us to a point where rsync can run extremely quickly. Those are the last remaining RPCs that we would need to make asynchronous to improve that kind of workload tremendously. We also have asynchronous metadata operations support in libCephFS that's currently under development. We expect that should be merged for Quincy. There's also some opportunities to improve the performance of CephFuse. There have been some recent changes to libFuse that we believe we could integrate into our CephFuse library to just take advantage of the latest kernel modifications that help us achieve better performance. Within libCephFS, there's efforts to break up the big client lock that will improve a lot of the performance for the asynchronous systems, even Fuse itself or NFS Ganesha. Currently, a lot of operations there are being blocked by the big client lock and slows everything down. We also are developing the FS cache support within the kernel client. Jeff Layton's been working on this. The FS cache interface is currently being refactored and reworked by David Howells, and the Ceph kernel client is being constantly updated to his latest changes, and we're hopeful that we can get something like that complete by the Quincy release. But of course, the kernel has its own release schedule, so they may not match up, or the kernel support may be finished before Quincy is even released. Another performance feature that we're looking into is recursive unlink RPC. Recursive unlink on a distributed file system is usually pretty slow, and a lot of workloads just want to throw it away and forget it. That's especially true within the new volumes plugin, which needs to regularly delete subvolumes, and it would be much faster to just tell the MDS an entire directory tree can go away. And that's a workload that we'd like to support through a new recursive unlink RPC, and probably that'll be exposed to the user as some kind of .trash directory to allow applications to be able to do that without linking to libCephFS. And we expect there should be some big wins there to offload that work off onto the MDS to be done incrementally. On a usability standpoint, we're looking to support MDS rolling upgrades. This has been something that's we realize is very difficult for Ceph clusters to upgrade the MDS due to the awkward procedure that must be followed. And this is something we want to try to address with the Quincy release. There's already some changes in flight to improve how we're handling the compatibility sets for the MDSs and the file systems to eliminate the need to actually stop MDSs and standbys prior to doing any package upgrades. This should simplify the procedure a lot, and then we can move on to rolling upgrades of multiple active file systems. We're also working on a libCephFS SQLite, which will be another client to CephFS. This will be the companion VFS to the new libCeph SQLite that's in Pacific. There's a link to the blog post for libCeph SQLite in the slides. libCephFS SQLite will function similarly in that it allows you to put a SQLite database on CephFS without actually mounting CephFS using the kernel client or CephFuse. So it can speak the CephFS protocol and avoid doing any mounts. Then we've also got the MDS memory target, and this is another configuration companion to the OSD memory target variable. And this is to improve how the MDS utilizes the memory by monitoring its own memory use and then adjusting its own cache as appropriate in order to meet the desired memory target. We have some code that's already been worked on that just needs picked up and polished for Quincy to get this in. And then for CephFS multi-site replication, currently we're working on more testing for the HA components of the CephFS mirror that's already present and adding active-active support. Both of those features we're planning to backport to Pacific. You won't need to wait for Quincy for those to be available. And make it more automatic to set up snapshots and sync it to the remote cluster to make that interface a little cleaner. And some of the other things we're looking at is some other sophisticated models for actually doing multi-site replication. Without any firm plans of doing this for Quincy, look at potentially bidirectional or loosely eventually consistent type synchronization mechanisms and some kind of simple conflict resolution behavior in tandem with bidirectional sync. The actual details of that have yet to be sorted out, and also how much that feature is in demand by community. So if you have any thoughts or a strong desire for this type of system, please do share on the mailing list. So, got a few minutes for QA if anyone would like to ask questions.
I have a question. Dan from CERN. Hi, Patrick.
Hello.
I'm wondering if there's any work on multi-threading.
Any work on multi-threading? The answer is there has been work, but due to the size of the problem, not a lot of progress has been made. Mostly just a lot of design discussion. So I would say no, not really any progress made.
Okay. Yeah, because we really noticed our MDS has really hit the CPU limits, and we tried to we were running 10 before, but this was operationally like kind of weird. So now we try to run maybe 3 or 4, and CPU seems to be a bottleneck. Okay. The other The other thing I was wondering is whenever there's like it happens very rarely, but whenever users hit like a crash of an MDS and then the journal can't be replayed, and then they have to enter into the disaster recovery uh, procedure, this is like extremely scary. So I'm wondering if there's any ideas to make that somehow less scary and maybe even more automatic. Something like
Yeah, I
a
think
okay, I think you understand, yeah.
yeah. the yeah, disaster recovery on CephFS can be frankly terrifying for users. The which steps you should follow is not always clear, and I think the MDS rightfully decides to turn itself off if it detects any kind of metadata damage and expects the administrator to come in and just take a look. There are tools to do that, of course, but which tools to use is not always clear. I think as far as improving the usability of CephFS, we could go a long way to um, be more clear about what the kind of metadata damage we've discovered. And in places where we do set the, there should be some suggestions on where to look, what tools to use, maybe try to classify the errors numerically so that they can be looked up more easily um, so administrators have somewhere to go immediately to see like what kind of metadata damage has been discovered and is it important? Can it just be deleted? Is it like transient metadata like the open file table? Things like that. That's something that I
Yeah.
think we could do a lot better on. Yeah. And it's certainly a solvable problem. It's just something that you have to spend time doing.
Okay. Thanks for the answers.
Any other questions? All
Oh,
right.
I had one more.
Go ahead.
Does does multi FS does that work with Rados namespaces in addition to separate pools per FS?
Um, no, we don't use we don't use a Rados namespace in the metadata pool. That's always been the case.
Okay.
And in the data pool, you can use Rados namespaces, but that's configured using file layouts.
Oh, I get, okay, yeah, I guess it would be really tricky to have Rados namespaces used for both multi-FS and for subvolumes. Okay.
There was
Yeah.
there were plans to do that, so you're not crazy, but it because of the recent changes in Rados to reduce the number of PGs that a pool needs to have, like you can have a pool with one PG and you don't see any errors or warnings anymore in Ceph. It made less sense to undergo the amount of development that would be required to share data pools or even metadata pools between file systems because pools are now so cheap. Uh, so that's why we didn't go ahead and do that.
Okay. But so, I mean, reasonably speaking, you would probably limit the number of file systems per cluster to tens of file systems, I guess, right? Do you think hundreds of file systems would work?
We have not identified a limit, but at some
Okay.
point the file system map would grow to a point where you might see slowdowns in unexpected places, probably the monitors. Uh, we don't we don't currently have an idea where that slowdown might exist, be in
Okay.
the tens of thousands.
Okay. Oh, okay. Because yeah, I think at the moment we have over 1,000 Manila shares in our cluster. I suppose we could look at because I think with the volume support you can do one CephFS, a separate FS per volume, right? Per let's say Manila share.
Yeah,
At least conceptually it works. So I wonder if a
it
thousand
could.
FSs would work. If we had the orchestration to do 1,000 MDSs, obviously.
Yeah, it would be possible, but the benefits there would be
Yeah.
uncertain.
Yeah, that's true. Okay, thanks a lot.
All right. Any other questions? Okay. Thank you all for attending. Please check the Etherpad for the upcoming events on the calendar. I'll go ahead and link that in the chat. All right. Thanks for attending. Have a good day, everybody.